Welcome to our May webinar. My name is Tracy, and I'm part of the team that puts together these monthly webinars, which are geared toward putting farmers in touch with top industry experts who can provide strategic advice on some of the key challenges encountered on farms today. Each month, we address a new issue that could be having an impact on productivity. We focus on strategies for dealing with that challenge, always keeping our eye on solutions that will boost farm productivity and profitability. In this webinar, we will be looking at how to use satellite imagery as an early warning system to help identify problems or issues that may be arising in certain areas of your crop. The main purpose of these vegetation maps is to allow farmers and their trusted advisors to clearly see the areas in the field where the crop might be having a problem. This is so that they can catch these problems early and determine if there's a cost-effective remedy that could correct the situation and restore their chance of achieving a healthy yield in that area. So why is early detection so important? Because it makes further investigation quick and accurate. This investigation could include soil or tissue sampling in that area, or maybe even include sending a drone to do a deeper dive. To take it one step further, and our expert will delve into this more deeply in a few minutes, these images are even more useful when they can be viewed right on your mobile device. This can really speed up the process of detection, diagnosis, and then pulling the trigger on any remedies that might be cost-effective. But at the end of the day, all of this depends on getting reliable, consistent crop health imagery maps that you can count on. A crucial point here is, and our expert's going to touch on that today, is the importance of tracking these crop health images on a regular basis. Now I'm excited to introduce our subject matter expert for this webinar. Viviane Faria is at the forefront of the world of remote sensing and GIS technology as it relates to agriculture. More specifically, her attention is focused on how these tools can be leveraged to help farmers maximize yields and drive productivity. In her role with the Trimble Ag Software product development team, Viviane, who has a master's in science in remote sensing and GIS from the Brazilian National Institute of Space Research, works to find ways to leverage remote sensing to help farmers maximize yield potential and grow profits. So let's get started. First, here's a quick overview of what we're going to cover in this webinar. We've briefly outlined already why good quality satellite imagery is so important and how it can play a big role in preserving yield. To provide some context here, Viviane is going to give us an overview of the options that are in the market today. After that, we'll go through the key considerations farmers will want to weigh as they begin to use crop health imagery to make decisions. Then we'll look at how growers can leverage the power of satellite imagery during the crop season, so actually in real time as the crop is growing. And throughout the presentation, we're going to refer to some real-life case studies and examples of how farmers are using satellite imagery today, so what's working, what's not working, and how to navigate this terrain if you're new to the world of crop health imagery. Then we hope you'll stay tuned until the end when Viviane will answer a few submitted questions. This is where we'll also be able to provide contact details so that you can send us any other questions you might have after watching this webinar. And now I'll pass it over to Viviane.
Thank you, Tracy. Hi, everyone. I'm going to start with this picture. These are the many images options offered in agriculture today. As you can see, there are a lot of players, and it can be very confusing to choose the right one. First, there are satellites, such as NASA, ESA, and Planet Labs, that are there in the space collecting images of your farm without you even notice. They can cover your entire farm at once at more competitive price, but the disadvantage here is that the images are limited by the cloud cover. Then we have unmanned aircrafts that have the advantage of flying under clouds. The downside is that you usually need to pay in advance and you don't have much flexibility to change the flight schedules. Last but not least is the unmanned aircrafts or drones. The advantage of these solutions is having very fine spatial resolution, flexibility on collection schedule, and ability to fly under clouds. But they are usually more expensive than the other options and are not easy to scale. In this webinar, I'm going to focus on satellites, and here are the key considerations you need to weigh in order to find the satellite imagery option that's best for your farm operation. Price, frequency and cloud detection at field level, spatial resolution, and some important corrections such as atmospheric condition and soil background noise. I'll walk through each of these on the next few slides. Let's start with Imagery Price. Here's a sample of the most common satellites used for precision agriculture. The main drivers of Imagery Price are frequency and spatial resolution. Frequency means how often a satellite will take a picture of your farm. Spatial resolution is the minimum area seen by the satellite from space. I'll explain this a little bit better later. As frequency and spatial resolution increases, the cost of image also increases. This is why you should always ask for the satellite specs when you are evaluating your options. The second important consideration when looking to invest in imagery is frequency and cloud detection at field level. The satellites we are talking about here use sunlight to see objects on Earth, including plants. The issue is that they cannot see anything under clouds. Here's a field seen from a satellite. The white patches are clouds, and the dark areas are cloud shadows projecting the field. If it's a cloudy day, the image from your field is useless. Frequency of image is important in making sure you get enough coverage of your field. The third consideration is spatial resolution, which is related to pixel size. A pixel is the minimum area of your field seen by satellite. To calculate the area, you basically multiply the width of the pixel by its length. So let's look at these examples. On the left, we have an image of 30-meter spatial resolution. That means that the minimum area seen by the satellites is 900 square meters. Each of those little squares in the zoomed area is a pixel that represents an area of 900 square meters in your field. Anything smaller than that is not differentiated by the satellite. In the middle image, each pixel represents an area of 100 square meter or 10-meter spatial resolution. And on the right, we have an image of 5-meter spatial resolution or 25 square meter pixel. As you can see, the images in the middle looks very sharp when compared to the left one. But the difference between the 10 meter and 5 meters is smaller. What I want to point out here is that since high resolution costs more, you always need to gauge if the improvement you're going to have is worth the extra money spent. This chart shows us why a high resolution not always worth the cost. Let's look at the blue section first. We can improve the resolution from 10 meters to 1 meter, but we won't create any more applications for ag. Basically, all this blue first level of applications, scouting, prescriptions, management zones, field status, can be done either with 10-meter pixel or 3-meter pixel. The only way to get at the next level of applications in ag is going down to centimeter resolution, which is the yellow section. However, that's not a place where a satellite can help today. The fourth consideration is normalization for sun angles and atmospheric condition change. This one sounds technical, and I won't spend much time with these graphs. Basically, the reason we need these calibrations is because the amount of sunlight that gets in the earth varies throughout the day and throughout the year. If these corrections are not done, we cannot compare one image to another. It's always good to check if these corrections have been done with your imagery source provider. The last consideration is soil background correction. And why soil correction is important? Well, let's look at this irrigation pivot and project a pixel of 10 meter by 10 meter in this field. Think about the distance between the rows in this crop field. How many will be averaged together to give a total of 10 meters with maybe 5 rows, 10 rows, even more? So satellite will not be able to put those crop rows and soil between rows apart. All the sunlight reflecting the 100 square meter area, which includes crop, wet soil, and dry soil, are going to be recorded in one single value. If you do not perform soil correction, the vegetation index value is not going to be precise and might mislead your scouting. Here's an example of NADVI and Trimble's crop health imagery in the same area and same date. As you can see, crop health imagery highlights the field variability. If you look at that pivot for a second, you'll see a section where NADVI did not show any difference. It's all orange. Crop health imagery on the right was able to detect that a crop was growing there. Crop health imagery was able to put apart an area that was already with some sparse vegetation, yellow-green, and another part that was still bare soil, in orange. This just explains how important it is to use a good index to highlight the field variability. Before walking you through a real-life example of using imagery of your field, I'm going to turn things over to Tracy that will give us a brief explanation of Trimble Ag software imagery features we're going to use.
Thanks, Viviani. Okay, let's quickly walk through 4 crop health imagery features that we'll see in Trimble Ag software. First, there's the vegetation index that's calibrated, the vegetation index that's classified, the natural color, or RGB, and the color infrared. They are all in 10-meter spatial resolution, and they're all available for download in GeoTIFF and shapefile formats. So when you go to Trimble Ag software, you're going to have the option to select your image type, and then these will show up in the image catalog. I'll go through each of them and explain a little bit about what they mean and just how these different image types can be used. The first is the vegetation index. This calibrated index enables day-to-day and even field-to-field comparisons. It also corrects for what we call soil noise and moisture background. It's normalized between satellites to produce a consistent vegetation index. And these satellites use a standard scale that goes from 0 to 120, which means non-vegetation to dense vegetation. Now let's look at why calibration matters. This slide helps us understand the value of calibration and why it's so important. So the first bar represents an uncalibrated index, and the second one is Trimble's crop health imagery, which is powered by PurePixel. PurePixel leverages a proprietary algorithm to analyze multiple sensor inputs to produce a calibrated vegetative index. And these maps, they can be presented throughout the growing season. So this unique calibration allows farmers to compare crop health at each growing stage, and that results in more targeted crop scouting and more effective resolution if there's a cost-effective remedy that can be found. Conversely, an uncalibrated index will not tell us the true values. It will stretch all the values measured of a field on a scale from less dense vegetation to highest dense vegetation. Showing this in crop health imagery along the bottom, you can see that these values are meaningful. In other words, we can tell that this young crop seen in the picture will only have values between 1 and 60, and the image is going to be seen in that color range. There will be no pixels with higher values than 60 because the crop canopy hasn't fully closed yet. In that way, we can monitor and compare crop field growth throughout the season. The second feature is the classified vegetation index, which is another way to express crop health to highlight the variability in the field. This calibrated vegetation index is divided into 5 classes of equal area. Each area represents 20% of the field and is classified from the lowest to the greatest condition of crop health. The map is color-coded according to the vegetation values. The first 20% will always be associated with the lowest performing part of the field, while the last 20% with the highest performing areas. This index is good for specifically for prescriptions, as long as you're doing some ground truthing as well. The other great thing here is that these images also flow into Advisor Prime, which is a new Trimble Ag software offering that's specifically for crop advisors and agronomists who are managing data for several different farmer clients. The classified index can also be used to optimize drone flights, to deploy a flight in the right part of the field instead of flying over the entire field, so you can save some money there. The vegetation index classified can also be used for scouting. If you don't have any imagery, how do you decide what spots of your field you need to look at first? By using crop health imagery, you can target scouting to the lowest performing parts of the field and then use our mobile app to guide you to the right locations. Then you can take notes and even decide to do some tissue sampling. Everything will be recorded on your mobile app. Then we have natural color, or RGB. RGB is color composition is expressed in the same colors that we see with our eyes. It can be used to identify objects in the field and ground truth the vegetation index values. You can use this to identify what's real crop versus what might be a water stream like a pond. So by switching between image types, you can check the spots in advance and even remove them from your scouting list, making your time in the field more efficient. The last feature is color infrared, which takes advantage of the near infrared range that's been sensed by the satellites, but not by our eyes. Near infrared is related to about 80% of the vegetation response. Therefore, this color composition highlights the vegetation variability that is shown in shades of red. The specific use here is to check the variation of vegetation that's not easily been seen in the natural color. Now I'm going to hand it back to Viviani, who's going to take us through a real-life example of how to use crop health imagery.
Okay, we talk about having more images throughout the season to monitor crop health, but what does it mean? How can you use them? Now, I'm going to walk you through a canola field from 2017 season. This field was seeded on May 18th and was harvested on September 5th. As you can see, the first image available was from May 20th. It was a couple of days after seeding, reason why the vegetation index values were low. However, there were some green patches in the image, and you probably wonder why. To understand what's going on, you can switch to RGB natural color and visualize that there were a lot of drainage in this field. And the green in the image is basically related to a slough area where some weeds were probably growing there. So nothing to worry about it. As season goes by, you receive other images like June 15th, June 22nd, and July 30th. You can see that the vegetation values have been increased as expected, since the crop biomass also increased with time. Then, on the image of July 10th, you notice that the vegetation values surprisingly decreased, and you want to check what happened. Again, you can switch to RGB and see that the entire field is yellow, which means that canola is on flowering. That dropped on the vegetation values is totally normal because of the spectral change that happened on the field. Well, now it's time to apply fungicide, and you can use the classified vegetation index for that. When you switch to the classified image, you see that some brown and orange areas match with the drainage, and you're probably thinking that you can decide to not apply fungicide in these locations and save some money. So that's the great use of crop health imagery. I just recommend you to do some ground truth before making this type of decision. But this image can be easily converted to an on and off prescription. Then the next image is from July 20th, and you can see that canola was still on flowering. Basically, you still have a chance to apply a second round of fungicide if necessary. On July 25th, the flower is over and the field is already back to green, reason why vegetation values are higher. And you can take advantage of the classified image to do some scouting on locations where you did not apply fungicide, just to make sure these areas haven't been hit by any disease. The following images show that the vegetation index starts to decrease, and the reason is because the crop is getting close to maturity. Basically, the amount of sunlight absorbed by the chlorophyll reduces, the plant starts to get dry, and this physiological change impact the spectral response. The image of August 27th shows that the field is already on senescence, and the crop is very, very dry, so the vegetation values are much lower. That tells us it's getting time to harvest. Then on the next image, September 90th, the field has already been harvested, and the image looks like soil again. Well, I hope this helped you to understand how powerful crop health imagery is. By switching between imagery types, you can now monitor your crop growth remotely and make a real-time decision either for targeting scouting or perform VR applications. The fact is that the more cloud-free image you have, the more efficient it becomes to monitor your fields. Now I will hand it back to Tracy.
Thank you, Viviani, for that great overview of how to leverage satellite imagery. We're nearing the end here. Just before we conclude, here's a slide just briefly outlining some of the key aspects of the crop health imagery feature in Trimble Ag software. As we've covered, it's an in-season crop health imagery solution based on multiple satellite feeds to help farmers monitor crop growth remotely and enable an early detection. The images are reliable and they are cloud-free, which saves you time. Crop health imagery is powered by PurePixel, which leverages a proprietary algorithm to analyze multiple sensor inputs. The end result? Calibrated vegetation index maps that can be used to compare crop health at each step of the growing stage. Also, customers get 3 to 5 cloud-free images per month. And then just to point out, it offers 10-meter spatial resolution and then the 4 image types that we went through earlier. Now I've got a few submitted questions for Viviani. I'm just going to jump in right here. The first one, this farmer says, okay, this all makes sense, but it's pretty overwhelming. How do I get started? Viviani, can you give us a sense of what the first steps might be when it comes to getting started with crop health imagery?
First you need to sign up for Farmer Pro or Farmer Pro license and add crop health imagery from the marketplace at no cost. And then my personal preference is starting with the vegetation index calibrated to monitor the crop health change from day to day. Then I use RGB or color infrared as a complementary image for ground truthing. And the vegetation index calibrated would be used for scouting or VR application. The good thing is that you can switch back and forth between the images types and find the sequence that works best for you. There's no rule here.
Thanks. Now for a second question. You mentioned the importance of seeing consistent images. How many is enough? And how many does Trimble send on average each month?
I would say the more the better, but one image per week or every 10 days is good enough. Trimble's product includes 8 image collections per month, but some of these images may be affected by clouds and are not delivered. The actual cloud frequency will vary depending on the weather conditions and geographic location. So, on average, a customer should expect to receive 3 to 5 images cloud-free per month.
Viviani, thank you for all the great information and strategic advice you've provided, and especially for the tips that will help farmers evaluate all of the offers out there and come up with the one that's right for them and for their farming operation. I would also like to thank all of you. We know you're busy at this time of year, and we appreciate you taking the time to watch this webinar. On that note, make sure to come back here in June when we'll be launching our new webinar topic for that month, which we will announce in the coming week here on our website and also in our newsletters and through social media. Thanks, and we'll see you back here in June.